Hi guys, let me do number 5 here just to show you using the same data how to adjust your level of confidence. So let's construct and interpret a 95% confidence interval for these data. Now in your study guide, 95% confidence when we're working with approximately normally distributed data, 95% confidence can be achieved by using z-scores of approximately 2. So to be technical, it's just slightly less than that. So let's make sure we understand how to find the critical value. So what I really want, I want to find the critical value, the z-score, that is so high that I capture the middle 95% of the sampling distribution. That means I'm cutting off the lower and upper 2.5%. To find that z-score then, I need to use the inverse norm command, but don't use 0.95. The percentile that you have to enter includes all of the area, including the 0.95 and the 0.025. All of that area together is 0.975. So the command that you need to use here, this is the inverse norm command, but the area that I want to put in is 0.975 for 95% confidence. Notice we get close to 2, it's 1.96. So I would memorize that 1.96 for 95% confidence. That's something that we're going to see quite a bit. So to build a 95% confidence interval, I'm going to start with my same average. We got that from our simple random sample. But this time I'm going to add and subtract 1.96 of our standard deviations. The standard deviation is the same. It's the standard deviation of the population divided by the square root of the sample size. It's about 2.17. So I'm using the same standard deviation, but to get more confidence, I have to use a larger critical value. That's going to increase the margin of error. 1.96 times 2.17, that gives me a margin of error of 4.25. So think about this. I want 95% confidence. That increases the margin of error. That makes wider confidence intervals. But that's the trade-off. If you want more confidence, you have to use wider intervals. Lower levels of confidence have narrower intervals. So here, if I start at that 1988.4, if I subtract my new margin of error of 4.25, that gives me a new lower boundary of 1984.15. The upper boundary then, if I take 1988.4 and add 4.25, that takes me to an upper boundary of 1992.65. So, my interpretation then changes just a little bit. In context, we can now be 95% confident that the true population mean penny date, that parameter, is between 1984.15 and 1992.65. So that 95% confidence, again, what it represents, it tells us that following this method, using the same sample size from the same population repeatedly over and over again, 95% of the intervals we build will capture the true population parameter, the true population mean penny date. 5% of the intervals won't capture the truth. So now understand, this happens to be one of the 95% that do capture the truth. The truth is at 1989.27. But be careful, again, that 95% confident is not a probability. This does not say that the probability is 0.95 that we have captured the truth. That is not what confidence levels represent. Confidence levels describe the method that you're using to build these boundaries, they do not represent a probability associated to these boundaries.